Hello everyone. Welcome back to Dr. Lou's VCE Science channel. Today, let's learn together about the 2023 chemistry exam in the Northern Hemisphere. We will focus on short answer questions related to electrochemistry. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. The standard electrical potential of silver ions is higher than that of nickel ions. So, the cathode is the silver ion/silver metal, and the anode is the nickel ion/nickel metal. In this cell, silver ion is an oxidizing agent and silver ions gain electrons from the reducing agent nickel metal. The cell voltage is calculated out by E cathode minus E anode. The answer to Kia is 1.05 V. To cancel electrons, we must cathode equation with multiple 2. Then, the equation of cathode and anode is added, and we get the final answer of Keb. Glucose can be oxidized by oxygen to carbon dioxide in water with different pathways such as respiration and combustion. But the over equation is independent of reaction pathways. The equation for respiration is the same as that for glucose combustion. Respiration is an exothermal reaction, so the energy of products must be lower than that of reaction. This cell is running in an acidic electrolyte. Question 3D asks the student to write half equation at the cathode. Oxygen is always an electron receiver in the cathode. Since the electrolyte is acidic, we select the equation of plus 1.23 volt. Some students may select an equation of plus 0.68 volts to produce hydrogen peroxide, but this is incorrect because its electrical potential is lower than that of plus 1.23. Half cells must be separated in any galvanic cells because the redox reaction transforms chemical energy into heat if half cells are mixed. Another reason is that keeps oxygen gas away from the cathode. Acceptable responses included the following. The half cells need to be separated so that electrons can travel between the two half cells in connecting wires through the load and the electrical energy harnessed. The bacteria are anaerobic, and the oxygen needs to be excluded from the oxidation half cell. If the half cells are not separated, electricity will not be produced. Or, if there was no separation of the two half cells, oxidation and reduction would occur together and electrons would not move through the external circuit. After electrons leave the anode and pump into the cathode, positive charges are accumulated in the anode and negative in the cathode. To balance the charge, hydrogen ions should move from the anode into the cathode as positive charges. This movement of hydrogen ions is repelled by a positive charge in the anode and attracted by a negative charge in the cathode. 1 mark was awarded for indicating the feature as an electrode, anode/cathode, or electrodes. 1 mark was awarded for linking the feature to the movement of H+ ions. An advantage of the fuel cell is that its reactants can be supplied continuously. As long as the reactants are supplied, the fuel cells keep working. But reactants cannot continue to supply to normal galvanic cells. Reactants are stored in normal galvanic cells only once. Here, biomass is used as a reactant in MFC. Biomass is renewable and cheaper. So, the renewable and cheaper are advantages of MFC over normal galvanic cells. However, the fuel cell is also one of the galvanic cells. Electrolytic cells transform electrical energy into chemical energy. On another hand, galvanic cells transform chemical energy into electrical energy, so electrolytic cells must contain electrical power. To produce a printed circuit board, we should supply copper ions continuously and keep the concentration of copper ions constant. The PT is an inertial metal and cannot supply copper ions. Copper metal can transform into copper ions, so the copper anode can continue to supply copper ions and keep the concentration of copper ions constant. Assuming 100% cell efficiency, we calculate the time for depositing 5.08 grams of copper on the PCBs. We know the amount of current and the mass of copper. Using Faraday's rule, we can calculate the time step by step. There are 4 steps we should be written here. Step 1. Calculate the moles of copper, 1 mark. Step 2. Calculate the moles of electrons, 1 mark. Step 3. Calculate the amount of electronic charge with Faraday's rule, 1 mark. Step 4. Calculate the time with the conception of current, 1 mark. The final result, time, has 2 significant figures because the current only contains 2 significant figures. Please pay attention to units. Mass is the gram, the amount is mole, the current is amp, the charge is coulomb, and time is second. This electrolysis cell is composed of PT and sodium hydroxide solution. PT is an inertial metal and not involved in the reaction. Because the concentration of sodium hydroxide is 1 mole, we can use a standard electrical potential table here. Solution always contains water, so water could be involved in electrolysis. Sodium hydroxide provides sodium ions and hydroxide ions. However, the standard electrical potential of sodium ions is lower than that of water, so it cannot be reduced here, but water can be reduced here. Half reaction in a cathode is when the water gains electrons and is decomposed to hydrogen gas and hydroxide ions. Since this electrolysis cell contains hydroxide ions lose electrons and are decomposed into oxygen gas and water in the anode. We find that hydroxide is consumed in the cathode but regenerated in the anode, so the hydroxide concentration is kept constant and the overall chemical reaction is simple electrolysis of water. There are 6 multiple-choice questions worth 1 point each, totaling 6 marks. There are also 2 short answer questions worth a total of 19 marks in the electrochemistry section. The overall score for this section is 25 points. With a total possible score of 120 points, the percentage for this section is 25.8% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lu's VCE Chemistry channel.